3, they want us to determine the values of x where g of x is greater than 0. That is the values of x where g of x is positive. We can answer that question directly from the graph. If you see here, this is the x-intercept, and you will see that the values of x to the left of this x-intercept will give you the value of this curve in the positive y-axis. It means that for values of x less than half, this curve of g of x will be in the positive y-axis. So the answer here will be x less than half. Right? So we can also solve that question mathematically. So g of x, right, is said we are looking for the values of x for which g of x is greater than 0. Now, g of x is 1 over x minus 1 plus 2. So we can set that greater than 0. So we can take the plus 2 to the other side. It becomes -2. Then we can rewrite this equation in the following ways, right? What you have on the left-hand side here is the same as what you have on the left-hand side here. We just use the principle of indices to express that. Next, we will look for a way to remove this -1. To remove that -1, we can multiply both sides by exponent -1. Now, once you multiply both sides by exponent -1, that switches this inequality sign from greater than to less than. So you have -2 exponent -1 on the right hand side. Let's try to do that. So this -1 times -1 here becomes +1. So x minus 1 exponent 1 remains x minus 1. And on the other side, you have -2 exponent -1, and that will be equal to -half. So we can transfer that -1 to the other side, and if we do that, it becomes +1. Now, 1 minus half will give us a half. So that means the values of x will be less than half. But you don't need to stress yourself going through this. You can just do this if you are preparing. The smartest and the fastest way to do that is just to look on your graph, and you can determine the values of x for which g of x would be greater than 0. That is, g of x will be positive. All right, so the next question is question 4.4. So for question 4.4, let's see what they're asking for. Determine the equation of the axis of symmetry of G for which, determine the equation of the axis of symmetry of G which has a negative gradient. So for we to do that, we must draw the axis of symmetry on the curve, on the graph. Right, to draw the axis of symmetry is simple. You just have to draw two diagonal lines across the point of intersection of the two asymptotes. Remember, the horizontal asymptote crosses the y-axis at 2, and the vertical asymptote crosses the x-axis at x equal to 1. So those are the two broken lines we have here. Right, so if you draw two diagonal lines, two diagonal lines through the point of intersection of the asymptote, those two diagonal lines are the axes of symmetry. two important things that you need to know about the axis of symmetry is that for the negative axis of symmetry, that is the one that runs from the top left to bottom right, for that negative line, the gradient is always -1. It does not change. The gradient is -1 no matter the scenario you are considering. And for the axis of symmetry that runs from the bottom left to top right, that is the positive line, the gradient will be 1. That is always the case, no matter the function you are looking at. So the axis of symmetry, the positive one, would have a gradient of 1. In the question, they are particular about the axis of symmetry, and they said the one with the negative gradient. So it means that we are dealing with this negative axis of symmetry. Therefore, the gradient there would be -1. So how can we determine the equation of this line with a gradient of -1? We know that this broken line, this axis of symmetry, is a straight line, and the equation of a straight line is y equals mx plus c. Already we have our m, the gradient, which is -1, and our task now will be to calculate the value of c, the y-intercept. How do we do that? All we have to do is to locate a point on that line that has both x and y coordinates. And luckily we have this point of intersection on that line, which has a coordinate of 1, 2. So now we just substitute the value of y equals 2 and x equals 1 into this. So we took this 1, 2 from this point. So it means the coordinate of x there is 1 and the coordinate of y is 2. So we substitute those values into this equation. So that is what we have here. Y is 2. Then the gradient is -1. The x value is 1. Then plus c. From there, we can calculate the value of c. So that means that c equals 3. That is the y-intercept. So if the y-intercept equals 3, it means that the equation of that line of symmetry, that axis of symmetry with a negative gradient, would be y equals -x plus 3. And that settles question 4.